Okay, so today we are doing, it's a lot brighter, huh? Okay, so today we are doing absolute value equations, section 2.2 in your textbook, and we need to go through a couple key terms first before we get into some examples. So the first one is apparent solution. This is important for us because what sometimes happens is we'll go through and solve an equation for whatever the variable is, and then if we were to go back and check it, it wouldn't actually fit in the context of the problem. This happens with absolute value problems sometimes. You'll see how that works in a little bit, but so you always want to go back and double check them. So an apparent solution is a solution to an equation. So it's a solution that is obtained by solving the equation. So EQN, that's my abbreviation for equation, but doesn't work when you plug it back in to check. So it's called an apparent solution because it apparently works, but it actually does not overall. Okay, but doesn't work when checking. Okay. All right, we can talk about conjunction and disjunction a little bit later, but for now, let's get into some examples. So it says on here, solve and check. And it's the same thing in your homework. It's fine by me if you want to check mentally, but you do want to make sure you go back and check because there are going to be some that are apparent solutions but aren't actual solutions in the long run. Okay, so let's just start out really easy here. The absolute value of x equals 7. The absolute value of x equals 7. Can somebody give me a number that I can plug in for x to make this sentence true? The absolute value of x equals 7. Michael?
7.
7. X equals, that's a good one. Okay. Any others that we can plug in? Jazz?
-7.
-7. Okay, good. Would we all agree with that? Okay. Okay. So if we plug both of those solutions back in, are they both true? Yes. Okay, so the absolute value of 7 is 7 and so on. Okay, let's try another one that's -4x equals 8. So the absolute value of -4x equals 8. Okay, so again, we're going to go through and actually there's a method to solving these that we'll get into in a minute, but first I want you to see why this method works just by looking at really easy versions of this. Okay, can somebody give me a number that we could plug in for this to make this statement true? Ashley, -2, okay. Is there another one that you guys can think of? Natalia? 2, good. Okay, and again, if we were to plug this back in, a mental check, -4 times -2, that's +8. The absolute value of +8 is 8, so that works. Oh, thank you. Okay. And then -4 times +2, that's -8. The absolute value of -8 is +8. Now let me show you one way, using the same problem, that we can get to the same conclusion, because they're not always going to be this easy. You can't just guess, right? So what we actually want to do is, once the absolute value is by itself, separate it into two equations. You take the absolute value bars off, -4x equals +8. And -4x equals -8. So it's a positive version of this number and a negative version. And that's actually what we saw in this first example when we solved it. And then solve each of these two equations for x. Okay, so let's move this up a little bit. So if we do that, we divide by -4, -4, -4. So x equals -2, and x equals +2. So you get the same thing, but again, most of the time you're going to get something inside of this absolute value that takes a little bit more than just guessing to get. Okay? Questions? Okay. Can I move this? You guys all have it? Am I going too fast? Too slow? Okay. Here we go. Let's see, the third one. The absolute value of 3x equals -6. Pay attention to this one. The absolute value of 3x equals -6. So there's something different about this problem than the other ones. So far, I mean, it looks kind of similar, I guess, to the last problem. But if we look at them, something that's a little bit different here. Anybody have any suggestions about this one? Kendra? Okay, so what the absolute value is equivalent to is negative. So, you guys tell me, what does the absolute value function do? Stephanie? It makes everything positive. So, can you plug in anything for this to make this equation true, ever? No. And why not again? Absolute value has to be positive. So, this one would be no solution. So if you were, and this is a good one as far as apparent solutions. If you were to go back and solve this, the same way you would get 3x equals negative 6, 3x equals positive 6, so you get x equals negative 2 and positive 2, but the absolute value of negative 6 is positive 6, not negative. So you have apparent solutions, but not actual solutions. Okay, let's spice it up a bit. Let's make, these are actually very easy so far. So 2 times 4x, the absolute value of 4x plus 6 equals 14. So 2 times the absolute value of 4x plus 6 equals 14. So we always want to make sure the absolute value is completely by itself before we do anything. So can someone make a suggestion about how we might get the absolute value by itself in this? Jared?
Well, we'll want to start by subtracting 6 and then divide that by 2.
Perfect. So 2 times the absolute value of 4x equals 8, and then divide by 2. So we're just trying to get the absolute value completely by itself. So the absolute value of 4x equals 4. And then from here, what next? Good. Okay. So this is where we want to separate it. If we're, I mean, at this step, I think we all can use common sense and say that x would be 1 and negative 1, right? Because 4 times 1 is 4. 4 times negative 1 is negative 4. But if you want to follow the procedure, negative 4, again, you just take what's inside of the absolute value, set it equal to the positive version of this number and the negative version, and you're good. So divide by 4, divide by 4. So x equals 1, and x equals negative 1. You always want to go back and do a check. So when you check it, you're plugging it back into the original equation, okay? So none of the ones that have been modified. But if we do that, 2 times, if we take that 1 and plug it back in, 4 times 1 is 4. The absolute value of 4 is 4. 4 times 2 is 8. 8 plus 6, does that equal 14? Yeah, and then same thing if you plug in the negative 1. Okay, how are we doing on questions? Still good? Yeah, Jade. Yeah, I know. We're actually about to go through one exactly like that. Okay, and that was a good question. So what does the apparent solution really have to do with anything? So let's find out. So here we go, number 5. Absolute value of 2x plus 7 equals 3x. There's actually a trick so that you can see right off the bat without solving it whether you're going to have an apparent solution that doesn't work or not. And this is one of them. Okay, and you'll see what happens in a minute. Okay, so on this, remember, is the absolute value by itself already? Yes. So now, if we're following that same process that we've been following, what would we do next? Break it up. So what is one of the equations when we break it up? Anybody in the mood to come up and solve this? Yeah, Riley? Okay. Everybody give Riley a round of applause for volunteering. Somebody follow along and see if you agree with what she's doing in each step. The lighting is so good. You can actually see everybody. It was so dark before. Okay, so x equals 7. How many people agree with that? Okay, how many people would agree if there were not absolute value bars around 7? Anybody? Okay, good. Everybody give Riley a round of applause. Thank you, Riley. Okay, so from this step, okay, I'm going to just take a couple of things off here. So we Don't need the absolute value around any of these. So those come off, and those come off. Here, here, and here. There's one other equation that we need up here. So what is the other equation? So 2x, she did 2x plus 7 equals positive 3x. What do we think about what the other one should be? So that's one of them. That's one of the apparent solutions. Rachel?
2x plus 7 equals
Good. Negative 3x. Okay, so then how would we solve this one for x? What would we do next? Anybody else feel like coming up? How many people are alive today? Oh, man. No hands went up. Okay, what do we do to solve this one for x? Akashni, is that a hand? Okay. Lydia? You want to come up? Okay, so everybody give Lydia a round of applause. Thank you. You guys want to see our game show?
Yeah.
It's really embarrassing. I'll show you after we finish our notes today. I think it's only embarrassing for me. Everybody else seems to be okay with it. Good. Negative 3 minus 2.
negative.
Negative 5x.
Oh, yeah.
How many of us are drama students? Okay. How many of us are musicians? You can keep solving. Keep solving. That's okay. Yeah, you can get a fraction. That's fine. Okay. You should get a fraction. How many people are musicians? Okay, visual art. That's good. Okay, dancing. How many of us like being on camera? Not in this sense. Okay, that's fair enough. Good. Okay. How many people clap if you agree with Lydia? Lydia. Okay. Here is the apparent solution thing. Jake, what's up?
Where do you have to even get negative 3?
This right here?
Yeah.
Okay. If I go back to this very first equation, notice how if the absolute value of x equals 7, we end up getting for our answer a positive version of whatever is inside the absolute value sign and a negative version. It's the same concept. So yeah, you always just change it to a positive and negative. Other questions? Okay, so here's the apparent solution thing. This is the one where I actually am going to write down the check because I want you guys to be able to see it. So we got x equals 7 and x equals negative 7/5. So let's go back. We actually want to check it in the very original equation. But before I do that, or while I'm writing this down, can anybody tell me whether it's not going to work for one or both of them? And why? Oh, sorry. What do we think? We got x equals 7 and x equals negative 7/5. Okay. Well, let's check then. 2x plus 7 equals 3x. Okay, so let's start with the 7 over here. So 2 times 7 plus 7, we want to see if the absolute value of that is the same thing as 3 times 7. So what is 2 times 7? 14, and 14 plus 7? 21. So does the absolute value of 21 equal 21? Yes. Okay, so this one works. Still can see that. Okay, now, the absolute value of 2 times negative 7/5 plus 7, that is not a fun one, I agree. Okay, 3 times, but I want you guys to look at this and use the logic that we just used with the whole absolute value equaling something negative. Does this end up being 3 times negative 7/5? What is that? Does that give us a positive number or a negative number? Negative. It gives us negative 21/5. Can an absolute value ever equal a negative number? No. So does x equals negative 7/5 work? No. Okay, so the only solution in this case is x equals what? 7. Perfect. Okay, so now, looking back, in the beginning, notice how there's a variable on the outside here. If you solve it this way and get a negative number for your solution, you can always say what about that negative solution? That's right. It's never going to work because a positive times a negative, you get it? Makes sense? Okay, how are we doing on questions? We're going to pause for a minute. We have visitors. All right, last problem. Last problem. List the elements in each set and then graph it. So list the elements. Make sure we're going. So list the elements in each set, then graph the solution set. Okay, so we will do one of these and then I think we will be good for the day. Okay, so this is how it's going to look. Curly brackets. So we have a curly bracket with a B, then a colon. It's funky terminology here. 6 times the absolute value of 4b plus 3 equals 6. End the curly brackets. Let me b colon 6 times the absolute value of 4b plus 3 equals 6. Make sure I got that right. Okay. So all this means, and the curly bracket. So what this is saying is, curly brackets are a fancy way of, it's what's called solution set. It's just a way of writing things. We saw that in some of our previous assignments, right? The answers in the book had the curly brackets. Okay, so all this is saying is be such that whatever we solve for B should be able to fit in this equation. Okay, so that's all it is. So basically it's saying solve the equation for B and then graph whatever numbers you end up getting on a number line. Isn't that a really nice way of saying that? To confuse us all. Whoops, we don't need 2 of them yet. Okay, so here we go. 6 times the absolute value of 4b plus 3 equals 6. All right, so we have an absolute value here, which means we want to get that absolute value, what? By itself first. So how would we do that? Akashni. Good, minus 3. Excellent. So 6 times the absolute value of 4b equals 3. Okay, next. Ashley. Divide by 6. We're not going to do much else with this fraction except reduce it. So 3/6 reduces to what? 1/2. Okay, so now we have absolute value equals what's on the right. So what would we do next? Akashni? Good. You divide by 4, but if you're following that same thing, once you have the absolute value by itself, if you're following that process, you do 4b equals a positive version of whatever the absolute value equals, and 4b equals negative version. All right, and now we're going to divide by 4 everywhere. Divide by 4 everywhere. Anybody remember that trick when we have a fraction over a whole number, Kashni? That's good when you're dividing. Okay, oh, I see what you're saying. Yes, perfect. There's actually a trick that makes it a lot quicker. So when you have a fraction divided by a whole number, you can just take the 2 bottom numbers and multiply them together. Did we talk about that in here? I don't remember. Was it you guys or 5th period? 5th period? You guys want me to show you how that works?
You showed us it was variables, so it was.
What's that?
You showed it to us, but it was with variables, so it looked different.
Oh, okay. Do you want me to look? Okay, so if we do the 1/2 divided by 4, that's the same thing as 1/2 divided by 4 over 1. So, oops, 4 over 1. So if we're doing what Akashni was suggesting, that's keep the top the same, change the division to multiplication, and flip the bottom. So that if we flip the bottom, 4 over 1 flips to 1 over 4, and then multiply, so we get 1 over 8. But again, if you look at the trick there, you end up getting the same thing, just in a little bit quicker way. Okay, how are we doing on questions? Oh, we're supposed to graph it. Okay. So here's 0, here's 1, here's -1. Let's see. 1/2. Whoop, thank you. So 1/2. 1/2. -1/2. If I want to put the number 1/8 and -1/8 on here, where would they be? Somewhere in here. Good. 1/2 and 0. Somewhere in, is that right? For positive 1/8? Okay, and then -8, -1/8 is on same distance on the opposite side. Okay, questions? Okay, so your homework for tonight, we are on homework number 7. It is page 49. Written exercises numbers 4 through 36, multiples of 4. It's a really short assignment. We good on questions? What's up, Jade?
Is it a game show?
Yes. Okay. Are we good? Let me